Hi, I'm Jose, the civil engineer, and this video is going to be a short-ish tutorial on how to model a wrench in gmsh. Now this wrench is part of the finite element class over here at Universidad Los Andes in Chile, where we have to model this wrench and do some stress analysis. But in order to do that, we need to start with a geometry that we can mesh. So this is what we're going to do here in this video. And this video is mainly meant for my students, but I'm sure it's going to help somebody else out there that is starting to learn how to use gmsh to model some more complex things. Okay, so let's start here. I'm going to open a terminal and fire up gmsh. In order to do that, I'm going to say gmsh wrench.geo. This is different if you do it on Linux or in Windows. I'm in Linux right now, so let's bring up that wrench.geo, and you can see that there's no file here. So in order to create a file, you actually have to add some geometry. Let's go and do just that. So the first thing I'm going to do is I'm going to add a circle for the head of the wrench. So let's go here, circle, and you can place it all around. You can see the coordinates being updated as I move this around. I actually want to be more precise, so I'm going to freeze the XYZ coordinates and place them manually. So at the origin, I'm going to place a circle of radius 29/2. You can do a little bit of math in these gmsh dialogues, which is really nice. So add them. There we go. So now I have a circle. Now the thing with this circle, I'm going to double click anywhere else in the screen and get rid of the axis, and double click again, geometry visibility, and go to surfaces. There are no surfaces, so in order to create a surface, what I want to do is to fill in the circle, right? This is just the circumference. So add a plane surface, select the edge of the circle, and press E. And now I have this cross, which represents a circle. I can go into the context menu and geometry options and set the aspect for the surfaces to be a solid, and it's going to show me a filled up surface, which is nice. But I'm going to go back to this cross because it's a bit handier when you're doing some modeling. So let's set the visibility, and let's add the not the curve labels but the surface labels to take a look at what's going on. So I have one plane, the curve labels. I also have a circle. Let's just not enable that for now. And now you can see that I have wrench.geo created in my folder. So what I'm going to do now is open that with my trusty Sublime text. Okay, so this is the .geo file. .geo is a language used by gmsh to specify a geometry. You can do it in Python too nowadays, which is pretty handy. But this is pretty powerful too, and that's the native language for gmsh. So we're going to be using this. Very important coffee one Friday afternoon. Okay, so what's next? What's next is that we need to carve out the tip of the wrench so that we can have the place where the bolt goes. So let's understand this geometry a little bit. There's an arc with a radius of 9 that is centered about a distance of roughly 6 millimeters away. So let's add a circle. And I'm going to do it now, not with the GUI, but with the geo file. Let's get rid of these comments, which are just there to separate commands. So this is the command sequence to generate a filled circle. And I'm just going to copy that and generate another circle. So all these ones get replaced by 2. And then I move 6 millimeters away in the X direction and reduce the radius from 29/2 to 9. And let's save this file, and I'm going to reload. Now to reload, I can go here and reload script, or I can press the 0 hotkey on my keyboard. There we go. Now we have a nice circle. Okay, that's nice. And now let's take out this rectangle over here. So this is how I'm going to do it. I'm going to add a rectangle now. Let's add a little rectangle. This rectangle is going to be having a width of 13, which is the width of the rectangle, 13 millimeters. Let's center that. So this is going to be minus 7.5, which is 13/2 in the Y direction. Right, and then let's give it a length of around 20. Sorry, this is not the length. This should be 0, and the length is going to be here, 20. So you can already see something is off though, because 13, the rectangle is not quite centered. Why is that? Why is it not quite centered? This should be, the width is 13 over 2. There we go. Did I do that math wrong? Oh, it's 6.5, not 7.5. Sorry, bad math. But that's where the being able to do some computations here comes in handy. Anyway, back to this. I'm going to move the rectangle so it intersects, it overlaps the circle quite nicely. So let's do exactly that. So maybe move it back like 4 centimeters. Yeah, about that. Let's add that rectangle. Okay, so now we see, I skewed this a little bit. This might happen to you. gmsh is actually 3D, but if I want to go back to the top view, I press this little Z button. I don't know, so that'll be Alt Z for the shortcut. So if I go Alt Z, I go back. Okay, great. So now we have 3 planes. Let's go here into the visibility tool, and we can see surface number 1 is that plane. Let's get rid of the axis for a second. Surface number 2 is the small circle, and surface number 3 is the rectangle we just added. So if I select these two, what I want here is to remove everything except for the center here of this figure and maybe the tip. That way, when I go back to the big figure, I can subtract that shape from the big figure. So let's do just that. I'm going to select these two things, and I'm going to go ahead and chop this up into the multiple pieces that make it up. So the way to do that is to do a Boolean fragments operation. So for the Boolean fragments, I'm going to select the circle, E, and I'm going to select as a tool the rectangle, E, Q. So you can see the figure got merged and split up into its component parts. Let's go into the text file real quick. You can see that after adding the rectangle, it comes the Boolean fragments operation. Okay, so what is this useful? Because I can go now here in and delete all the pieces I don't want, which are these. Get rid of those. And now I'm going to take a look at everything. Everything is like that. So now, with this new shape I've created over here, I'm going to subtract that from this to get the wrench head. So let's go ahead and do that. I'm going to do a Boolean difference operation over here. Let's select this as the main object, E, and now the tool is going to be these two pieces over here, plane 2 and plane 6, and when I press E, bam, that's when I get the head over here, except the head is a little bit tilted. So let's go ahead and rotate that. I'm going to use the transform option, rotate, select here what I want to rotate, and then in the dialog over here we have we have to set up an axis of rotation. So that's about the origin, and in the Z direction. A Z direction rotation is going to be a counterclockwise rotation according to the right hand rule. So set that axis, and how much are we going to rotate? We're going to rotate 17 degrees times pi over 180. So this factor over here, so that we can convert from degrees to radian. And when I press E, you get just the right rotation, which is not specified in the drawing. You actually have to watch this video to know it's 17, or you have to make some guesses. The 17, I think is some sort of standard rotation for the head of these things. Anyway, let's continue. So what's next? Next is let's work a little bit on the handle. Let's work on the handle. The handle is, let's start with a rectangle with a length of 110 and a width of 11. So let's go into the GUI and rectangle tool. There you go. I have the rectangles frozen. So let's put XYZ coordinates in 0, 0, 0. The DX I'm gonna set to 110, which is the length of the handlebar, and then the dy is 11, which is the width of the handlebar, and let's add just that. Now that's not exactly where I want it. Let's get rid of the axis. I'd like this to be centered. So in order for this to be centered, I go back to the gmsh file, or I could do it right away on the GUI. But here I want this to be at -110/2, and then 11/2, -11/2. Save, press 0 to reset, and there we go. Next thing I want to do is move the head over to the tip. In order to do that, I'm going to translate the head. And here, using the translation operator, be very careful with this. The Z has to go to 0, and I'm going to move all the way to the tip, which is at 110/2, sorry. And that should move it to the right spot. Okay, this is just great. So then the next thing I want to do is I want to chop off this part over here. So to do that, I'm going to do a Boolean difference operation on plane 2, where I'm going to subtract the head. But I want to keep the head, so that this is going to mean that this is going to be done by not deleting the tool after the subtraction. So here we go. Sorry. Difference, select the main body, E, select the tool, E, and we're done. So now the body is split into 3 planes. I can go ahead and delete this little chunk over here, and that looks pretty much how we want it to look. Now, here's the problem with this geometry. I want to start thinking about meshing. Okay, so I can go here to the mesh module and go mesh 2D, and even enable 2D element faces. And you can see this is a mess. If we go to mesh, we can make the mesh a little bit nicer. I'm dragging here on this dialog, text dialog, to like 0.2, and then to remesh, I'll do 1 and 2, or press keys 1 and 2. Now you can see here that the nodes or the meshes for these two geometries are non-conforming. If I go to visibility and enable the node labels and disable the element faces, you'll see that the nodes are duplicated. Sometimes the nodes are duplicated, and they're can be tricky if they're on top of each other. You can't see that they're duplicated. But if you switch on the node labels, the numbers are going to be on top to show that they're duplicated. So in order to unduplicate them, so merge these two geometries, I'm gonna apply this command over here, coherence. When I apply that, everything's merged, but we now need to generate 2 meshes. Let's just show you real quick. Before I do the coherence, let's go now and reload over here. Let's enable geometry curve labels like this. So you have circle 16, which I think is this one, and then there's a circle 19, which is that arc, I guess. Circle 13, which is that other arc. The thing is, when I do coherence, everything gets merged into one big thing. You can see things moved around a little bit. Now when I mesh, now you can see that the meshes are conforming. There's one node on this line and not several of those. You can see now that the triangles look nice. So this is something that you have to be careful when meshing. Make sure your meshes are nice and conforming so that the geometry is one single thing. Okay, let's get rid of this and let's reload. And let's get rid of the curve labels like this. But we'll keep the surface labels for now. We just reload. There's 2 coherence commands. The nice thing about keeping the text file open is that you can undo everything, because gmsh doesn't have an undo tool, but you can achieve the same thing and even more powerful by just editing the .go file. Okay, so here we are. Here we stand. We're going to do one final thing, or I guess two final things. But the first thing I want to do is to generate this nice curved geometry over here. So in order to do that, let's take a little screenshot and show you the geometry that's involved, because we're going to have to compute, where the center of this radius 23 arc is here, and where it starts and where it ends. So let's go into some expand canvas. Okay, so here we're in Pinta, which is a really bad program, but the idea here is that this arc of a circle, oops, wrong tool. Let's go here in red or in blue. Let's choose this blue. This arc of a circle goes from here to here, and it's obviously tangent here, but it's tangent here. So that means there's a line that goes here to the radius, and that's at 90 degrees from this circle, and that also means I can extend that line over here and then intersect that with this line, and that's going to give me the location of the center of the arc with a radius of 23 that I need to use to generate that little arc over there. So I'm going to take a look at not that triangle. In order to get the coordinates, I'm going to look at, oops, wrong tool again. Let's go red. Over, wow, why does the tool keep changing? I don't know. There we go. This triangle, very shaky right now, here. Now that triangle here, and I'm going to redraw it real quick. I'm just going to use the blue line. Okay, so I know this radius is 9, I know this radius is 23, and I know this is 11, so this is half of 11, so this distance is going to be 11 over 2, right? And this is going to be 23. So that tells me where to place the center. So in the minus y direction, I'm going to go to minus 11 over 2 plus 23. And in the other direction, I'm going to use Pythagoras theorem to figure out what that x direction is. So real quick, this is going to be 23 plus 9. All of that squared is going to be equals to x squared plus 11 over 2 plus 23 squared. So I'm going to go ahead and use gmsh to place this, to solve for this equation with high accuracy. So let's go back. Let's keep this equation over there handy. But I'm going to place a circle, a new circle. So we're going to reuse this little module over here. We're going to call that circle number 3. Over here, let's change all those numbers to 3. Although 3, yeah, because it's going to be a 3. I just need to make sure the number doesn't clash. So I have surface 1, surface 2, and this is going to be surface 3. I have purchased Sublime Text, but I haven't added the license to this computer, so that's kind of embarrassing, but that's where we are. Okay, so the problem here is the radius is going to be 23, that's this number over here, and I need to see where the center is, x0 and y0. So I'm going to define those to be variables, and I know that y0 is going to be 11 over 2 and 23. So let's go here, minus 11 over 2, minus 23. That should be fine. And x0 is going to be the square root of this guy minus this guy. So let's write that, SQRT, with a capital S for some reason. With a capital S is going to be, so the radius, which is 29, I think gmsh uses that symbol for squared. Sorry, 29. Sorry, 23 plus 9. 23 plus 9 squared minus, basically what I'm calling all this opposite angle is y0. y0 squared, like this, and let's place that circle at that point, save, go back to gmsh and see what happens. Oops, it's not in the correct location. Let's see what happens. I probably have to shift it. So that's gonna be from this point over here. So I have to go x backwards from 110. So let's go that backwards from 110 over 2, like so. That doesn't look right. Did my math go wrong somewhere? Radius, that radius is not 9. Sorry, that's the mistake. That it's 29. That radius is 29. Okay, so the mistake is here. This number is not 9, it's 29. Sorry about that. But at this point, I'm not going to. 23 plus 29, let's reload. 23 plus 29 over 2. That is 29 over 2. So let's just do that, reload. Oof, there we go. Sorry about that. Okay, so now what I want to keep actually is it's this part over here. I don't even have a plane over there. So what can I do is I'm going to add something and then subtract things. Let's add, now you have to be careful about this. You don't want to add points in places where you don't need points. So let's be careful. I'm gonna do it like this. Let's add a rectangle. So I'm gonna start my rectangle at why can't I see a rectangle? It's a small rectangle. 10. Okay. So let's move this rectangle down by 11 units. 11 units, places it right there. Why is that where 11 units is at? At some point everything got moved. You can see the axis here is, the axis is actually not making any sense. Did I move everything around for some reason? Let's quickly reload. Something's not making sense. Okay, let's add that rectangle at minus 11, 110. And minus 55, something like that. So it's like the handle, except it contains a little bit more. Minus 11. Minus 11 places it all the way down here. Minus 11 over 2 places it where it's supposed to be. So let's go minus 11 over 2 minus 11. There we go. Is this what I want? Is this what I want? Is this what you want, Abel? And these circles seem not to be touching right there. So I just want to keep this, and I want to introduce as little defects as possible into the mesh when doing this. So let's add this and see what happens. Let's see what happens. So I can, let's do fragments between this guy and this guy, and we get rid of all that is unneeded. So let's delete this, this, and this. This, get rid of that. So I have a little bit over there. And I'm gonna enable taking a look at solid. So this is plane 8, this is plane 8. This is a single plane right here. So that's not good. That is not good. Let's, what if we do, this is not going to be useful. Plane 1, let's go to cross. This is a single plane. Let's now go and do fragments between this guy and this guy. Sorry, fragments here and here. So now we can do delete this, and let's do coherence to bring everything together, or even better, there seems to be two planes here. Let's do a union between this and this, for example. Does that make sense? And then coherence. Yeah. So, well, that's one approach. As long as we keep, like, the problem here is this, like the mesh is over here is looking really bad. So maybe we can try, maybe we can try a different approach. What we'd want is just to keep this and to avoid breaking anything else. So maybe what we can do is we can have the rectangle. Let's go back a little bit and just go all the way to adding the, let's go here. So I have the circle and the rectangle, and maybe what I'm going to do is going to add another circle that I subtract from the rectangle, and then from the rectangle I subtract this other piece. Let's see. Let's add a new circle, like this one, but at the location of 110/2. We'll call this guy number 5. Let's see if that works. Something with tag 5 already exists. So let's add it through the GUI because the tags are taken. So let's go here, circle, and we want a circle at 110/2, 0, 0, 29/2, and that's exactly what I want. That circle, and then I'm going to make a plane surface out of that circle. Okay, I have my plane 5. So then I'm going to difference the rectangle, and I'm going to delete the tool from the new circle I created. This one. I pressed the wrong button. Difference this one from this one. There we go. And now I can subtract difference this guy and take away this guy, and then I have plane 4, plane 5, and I can delete. This is much cleaner. This is much cleaner. And now I have a mesh. This is non-conforming, but then I can make a coherence like this, and then they're conforming meshes. Okay, so that pretty much ends the tutorial. One last thing I want to do, because from here you can replicate those steps and do the rest of the geometry. Be very careful about how you mesh things. I'm just going to show, like what you want to do is define a physical group. So you go here, define, or where is it? Sorry, physical group here, define, add a new, for example, we need this part to be of a different thickness. So I can add a surface physical group, and I'll call this, for example, the head, like so. Select, add, and then let's add another physical surface, call it the handle, and I'm going to include this and this. So when you go to visualization, visibility, you can go by physical groups, and now you can see the head is just that and the handle is just that, or you can select both at the same time. And then you might want to have different physical groups for the different parts of the mesh, which is, for example, here, how much length you want to put here. Well, this is a value that you have to specify. It's an open question what this L is. But then all this top part needs to be a physical group of itself, because that's where the pressure of the hand is. So I would go here and add a curve physical group, physical curve, and let's call this pressure. I'll select that little arc over here, and now I have that arc. And on the other side, I'd go and grab the appropriate pieces and add that to another physical group. And the final thing is, in order to 3D print this, you're going to want to extrude it. Now, for the 2D stress analysis, you're not going to need a 3D mesh, but for the 3D printing, you can actually go here and selectively extrude. So one part of the mesh has a thickness of 3, and the other head has a thickness of 5. So I can accomplish that by extruding 1.5 in each direction. So let's go back here and quickly let's extrude by translation, and we're going to extrude in the Z direction by 1.5, the handle, and this, and the physical, sorry, not that one, undo last selection. I want to select the physical surface, all of that. I'll extrude one way, and then I can extrude the rest, which is 1.5, 2.5. I need to extrude 1 millimeter, the top part here. So this, let's extrude by translation. Where is that? Translate over here, extrude by 1 millimeter, E. There we go. And now we can mesh in 3D and get rid of the visibility of the labels. And then you can replicate this downward and do the same thing, the same extrusion. That's how you get the volume, and then you need to take care of this part over here, which is a shorter part, which is actually has a thickness of 1.6 instead of 3. So all those things are left up to you as an exercise. Okay, this has been a not so short video, but thanks for hanging in here, and I'll see you guys next time.